A collision avoidance system is an automobile safety system designed to reduce the severity of an accident. Also known as precrash system, forward collision warning system or collision mitigating system, it uses radar and sometimes laser and camera to detect an imminent crash. Once the detection is done, these systems either provide a warning to the driver when there is an imminent collision or take action autonomously without any driver input. Collision avoidance by braking is appropriate at low vehicle speeds, while collision avoidance by steering is appropriate at higher vehicle speeds. Cars with collision avoidance may also be equipped with adaptive cruise control, and use the same forward-looking sensors. History: the world's first demonstration of forward collision avoidance was performed in 1995 by a team of scientists and engineers at Hughes Research Laboratories in Malibu, California. The project was funded by Delco Electronics, and was led by HRL physicist Ross D. Olney. The technology was labeled for marketing purposes as forewarn. The system was radar-based, a technology that was readily available at Hughes Electronics, but virtually no place else in the world. A small custom-fabricated radar head was developed specifically for this automotive application at 77 GHz. The forward radar head, plus the signal processing unit and visual audio tactile feedbacks were first integrated into a Lexus SC400, and shortly thereafter into a Cadillac STS. An SUV-style concept vehicle known as SSC, that contained many other of Delco's most advanced technologies, also received the forewarn collision avoidance system and was shown to the public for the first time at the North American International Auto Show at Cobo Hall in Detroit in 1996. This was a fully functional vehicle, and demonstrations were concurrently being provided by a duplicate vehicle. While primarily a warning system, with various feedbacks, the system did have minor control of the brakes which were pulsed to begin a braking action in the event of a potential collision, making it also the beginning of avoidance systems. These SSC vehicles were sent around the world, including Europe and Asia, to share this very important life-saving technology with all the major automotive manufacturers in an effort to quick-start their individual development efforts. It took almost 20 years for this important technology to reach the consumer marketplace. In the early 2000s, the U.S. National Highway Traffic Safety Administration researched whether to make frontal collision warning systems and lane departure warning systems mandatory. In 2011, a question was submitted to the European Commission regarding stimulation of these collision mitigation by braking systems. The mandatory fitting of advanced emergency braking systems in commercial vehicles will be implemented on November 1, 2013 for new vehicle types and on November 1, 2015 for all new vehicles in the European Union. This could, according to the impact assessment, ultimately prevent around 5,000 fatalities and 50,000 serious injuries per year across the EU. A 2012 study by the Insurance Institute for Highway Safety examined how particular features of crash avoidance systems affected the number of claims under various forms of insurance coverage. The findings indicate that two crash avoidance features provide the biggest benefits: autonomous braking that would brake on its own, if the driver does not, to avoid a forward collision, and adaptive headlights that would shift the headlights in the direction the driver steers. They found lane departure systems to be not helpful, and perhaps harmful, at the circa 2012 stage of development. Collision avoidance features are rapidly making their way into the new vehicle fleet. Automobile manufacturers. Audi 2006, braking guard radar-assisted forward collision warning introduced on Audi Q7. 2010, Pre-Sense autonomous emergency braking system uses twin radar and monocular camera sensors and was first introduced in 2010 on the 2011 Audi A8. Pre-Sense Plus works in 4 phases. The system first provides warning of an impending accident, activating hazard warning lights, closing windows and sunroof, and pretensioning front seat belts. The warning is followed by light braking to get the driver's attention. The third phase initiates autonomous partial braking at a rate of 3 mph². The fourth phase increases braking to 5 mph², followed by automatic full braking power, roughly half a second before projected impact. Pre-Sense rear, is designed to reduce the consequences of rear-end collisions. The sunroof and windows are closed and seat belts are prepared for impact. The seats are moved forward to protect the car's occupants. 2015 introduced the Avoidance Assistant intervenes in the steering to help the driver avoid an obstacle. If an accident occurs, the turning assistant monitors opposing traffic when turning left at low speeds. In critical situation, it brakes the car. Multi-collision brake assist uses controlled braking maneuvers during the accident to aid the driver. Both systems introduced in 2015 on the second generation Q7. BMW 2012 BMW introduced two systems on the 7 Series. Active protection detects imminent accidents to pretension safety belts, close windows and moonroof, bring backrest of the front passenger seat to an upright position, and activate post-crash braking. A driver drowsiness detection includes an advice to take a break from driving. An active driving assistant combines lane departure warning, pedestrian protection, and city collision mitigation. In 2013, Driving Assistant Plus was introduced on most models, combining the front-facing camera, line departure system, and in some cases front radar sensors to detect vehicles ahead. Should the driver not react to the warning of a potential collision, the system would gradually prime brake pressure and apply a gyro with maximum deceleration power, if necessary. In the case of a crash, the system can bring the vehicle to a standstill. The Driving Assistant Plus package also includes approach and pedestrian warning with city brake activation. The system detects vehicles driving ahead and, at speeds of up to 60 km per hour, also persons who are approaching with possibility of collision. The driver is warned by visual and acoustic signals, and should the driver not react to the warning, and the range falls into the software programming, braking will be activated to reduce speed and help mitigate the critical situation. Later iterations of the system on cars equipped with automatic cruise control system are improved by combining radar and camera detection during fog, rain, and other situations where normal camera operations may be compromised. Cadillac In 2012, Cadillac introduced two systems on the Cadillac XTS, now also available on ATS, CTS and Escalade. The Ford Collision Alert uses a camera to detect and warn you when an impact may be imminent, and the front and rear automatic braking to detect when a frontal or rear collision is imminent and automatically applies the brakes to lessen impact severity, helping the driver avoid certain low-speed impacts. The automatic braking also functions at low speeds when a collision is imminent. Chrysler 2010, the 2011 Jeep Grand Cherokee introduced Ford Collision Warning. 2014, Chrysler 200 and 300 introduced full-speed Ford Collision Warning with active braking. The system readies the brakes and alerts the driver when it senses a potential frontal impact. If the driver does not respond and the risk of a collision continues, the brakes can bring the vehicle to a full stop. Advanced Brake Assist will increase the brake force automatically if the force applied is not sufficient. Fiat's autonomous emergency braking system, dubbed City Brake Control, is an urban low-speed crash avoidance system that works between 5 and 30 km per hour. It was first made available as an option on the third-generation Panda. It was also made available on the 500L and its variants. The system employs a laser LiDAR sensor located on top of the windscreen. If an impending collision is detected, it intervenes in 3 steps: brake pre-fill, enhancing the hydraulic brake assist sensitivity, and if the driver still has not reacted, it automatically applies the brakes and warns the occupants through a buzzer. In 2013, City Brake Control was tested and deemed effective by Euro NCAP, obtaining the Euro NCAP Advanced Reward. Ford In 2009, Ford introduced the collision warning with brake support on the Lincoln MKS and MKT and the Ford Taurus. This system provides a warning through a head-up display that visually resembles brake lamps. If the driver does not react, the system pre-charges the brakes and increases the brake assist sensitivity to maximize driver braking performance. Ford demonstrated its obstacle avoidance technology relying on a mix of sensors, including a camera behind the rear view mirror, to scan the road for vehicles and pedestrians so as to steer away if the driver does not take any action. General Motors 2012 Grams's collision alert system is introduced in the GMC Terrain SUVs and uses a camera to provide warning when there is a vehicle ahead or there is a lane departure. In 2013 the 2014 Chevrolet Impala received the radar and camera-based crash imminent braking. Radar technology detects a possible crash threat and alerts the driver. If the driver does not appear to react quickly enough or do a SNA unregistered trademark T react at all, this feature intervenes to apply the brakes in an effort to avoid the crash. Forward collision alert, lane departure warning, side blind zone alert. Using radar sensors on both sides of the vehicle, the system OE looks for other vehicles in the blind zone areas of the Impala and indicates their presence with LED lit symbols in the outside mirrors. Rear cross-traffic alert features. The 2016 Chevrolet Malibu will feature forward collision alert with following distance indicator, adaptive cruise control with front automatic braking and front pedestrian alert with last-second automatic braking. Honda In 2003, Honda introduced the first pre-crash system with autonomous braking on the Inspire and later in Acura, using a radar-based system to monitor the situation ahead and provide brake assistance if the driver reacts with insufficient force on the brake pedal after a warning in the instrument cluster and a tightening of the seat belts. The Honda system was the first production system to provide automatic braking. The 2003 Honda system also incorporated an e-pretensioner, which worked in conjunction with the CMBS system with electric motors on the seat belts. When activated, the CMBS has 3 warning stages. The first warning stage includes audible and visual warnings to brake. If ignored, the second stage would include the e-pretensioners tugging on the shoulder portion of the seatbelt 2 to 3 times as an additional tactile warning to the driver to take action. The third stage, in which the CMBS predicts that a collision is unavoidable, includes full seat belt slack take-up by the e-pretensioner for more effective seatbelt protection and automatic application of the brakes to lessen the severity of the predicted crash. The e-pretensioner would also work to reduce seat belt slack whenever the brakes are applied and the brake assist system is activated. In late 2004, Honda developed a night vision system that highlights pedestrians in front of the vehicle by alerting the driver with an audible chime and visually displaying them by a HUD. The system only works in temperatures below 30 degrees Celsius. This system first appeared on the Legend. Hyundai Genesis DH features automatic emergency braking that uses radar and windshield camera. Mazda's Smart City Brake Support System uses lasers to detect vehicles or obstacles in front of the car. The system is able to apply the brakes and cut engine power, and if the difference in speed between the car and the obstacle is 30 km per hour or less, the system can avoid or at least lessen potential damage from a collision. Mercedes-Benz In 2002 Mercedes pre-save system was unveiled in the fall at the Paris Motor Show on the 2003 S-Class. Using electronic stability control sensors to measure steering angle, vehicle yaw, and lateral acceleration and brake assist sensors to detect emergency braking, the system can tighten the seat belts, adjust seat positions including rear seats, raise folded rear headrests, and close the sunroof if it detects a possible collision. A later version of the pre-save system was supplemented by an additional function that can close any open windows if necessary. In 2005 Brake Assist BAS Plus was Mercedes-Benz's first forward warning collision system, introduced on the redesigned 2006 W221 S-Class, incorporates the autonomous cruise control system and adds a radar-based forward collision warning. In 2006, the pre-safe brake on the CL-Class C216 was the first partial autonomous braking if the driver does not react to the BAS Plus warnings and the system detects a severe danger of an accident. In 2009, Mercedes introduced the first pre-safe brake with full autonomous braking with maximum braking force approximately 0.6 seconds before impact, on the Mercedes-Benz E-Class. In 2011 occurred the introduction of the radar-based assistance system in the B-Class. In 2013, Mercedes updated pre-save on the redesigned W222 S-Class as Plus with cross-traffic assist. Pre-save with pedestrian detection and city brake function is a combination of stereo camera and radar sensors to detect pedestrians in front of the vehicle. Visual and acoustic warnings are triggered when a hazard is spotted. If the driver then reacts by braking, the braking power will be boosted as the situation requires, up to a full brake application. Should the driver fail to react, pre-safe brake triggers autonomous vehicle braking. Pedestrian detection is active up to approximately 72 km per hour, and is able to prevent collisions with pedestrians autonomously from an initial speed of up to 50 km per hour. A radar sensor in the rear bumper monitors the traffic behind the vehicle. If the risk of an impact from the rear is detected, the rear hazard warning lights are activated to alert the driver of the vehicle behind. Anticipatory occupant protection measures, such as the reversible belt tensioners, are deployed. If the vehicle is stopped and the driver indicates a wish to remain stationary by depressing the brake pedal, activating the hold function, or moving the selector lever to PA, the system increases the brake pressure to keep the vehicle firmly braked during a possible rear-end collision. Pre-safe impulse works in early phase of the crash. Before the resulting deceleration starts to increase, the front occupants are pulled away from the direction of impact and deeper into their seats by their seat belts. By the time the accident enters the phase when loads peak, the extra distance they are retracted by can be used while dissipating energy in a controlled fashion. Pre-acceleration and force limitation allow the occupants to be temporarily isolated from the effects of the crash, significantly reducing the risk and severity of injuries in a frontal collision. Mitsubishi available on Outlander is Mitsubishi's forward collision mitigation, adaptive cruise control, and lane departure warning system. Forward collision mitigation is designed to help avoid or reduce the crash speed in certain frontal collisions. Adaptive cruise control is not a collision avoidance system or an automatic driving system. The lane departure warning system is designed to read lane markers under certain conditions. Nissan's Infiniti brand offers both laser-based and radar-based systems. Brake assist with preview. Preview function anticipates the need to apply emergency braking and pre-pressurize the brake system to help improve brake response. Intelligent brake assist with forward emergency braking uses radar to monitor approaching speed to the vehicle ahead, helping detect an imminent collision. It provides a two-stage warning to alert the driver, and if the driver takes no action, the system automatically engages the brakes to mitigate collision speed and impact. Predictive forward collision warning system warns the driver of risks that may be obscured from the driver's view. It senses the relative velocity and distance of a vehicle directly ahead, as well as a vehicle traveling in front of the preceding one. Forward emergency braking. When the system judges that deceleration is required, it alerts the driver using both a screen display and sound, then generates a force that pushes the accelerator pedal up and smoothly applies partial braking to assist the driver in slowing the vehicle down. When the system judges that there is the possibility of a collision, it will automatically apply harder braking to help avoid a one. Peugeot 2014, Peugeot introduced active emergency braking system on 2014 Peugeot 308. Renault 2014, Renault introduced radar active emergency braking on 2015 Renault Espace. Skoda introduced 4 new security system in 2013, alongside other car models of the VW Group. The systems include multi-collision brake, crew protect assist, lane assistant and front assistant. The first Skoda model with these new systems was the Skoda Citeo in June 2012, along with the VW Up and the Seat Mii, the new Skoda Octavia. Subaru In 2008, Subaru introduced the JAR eyesight system to Japanese drivers on the legacy sedan, wagon and Outback, which, unlike radar-based systems, uses 2 CCD stereo cameras mounted to the roof beside the rear-view mirror. This system also offers lane departure warning and adaptive cruise functions. As of model year 2014, it is optional on the Legacy, Forester, or Impreza. and only on vehicles with the automatic or CVT transmission. In 2014, Subaru updated the system using cameras that can detect color and reducing the bulk of the system. Tesla The Tesla Model S has a feature known as Collision Avoidance Assist that automatically engages the brakes to reduce the impact of a frontal collision. Automatic emergency braking will stop applying the brakes when the driver presses the accelerator pedal, the brake pedal, or sharply turns the steering wheel. Toyota Toyota's pre-collision system was the first production Ford collision warning system. The radar-based system that uses a forward-facing millimeter wave radar. When the system determines that a frontal collision is unavoidable, it preemptively tightens the seat belts, removing any slack, and pre-charges the brakes using brake assist to give the driver maximum stopping power instantly when the driver depresses the brake pedal. 2003 February, Toyota launched PCS on the redesigned Japanese domestic market Harrier. 2003 August, added an automatic partial pre-crash braking system to the Celsior. 2003 September, PCS made its first appearance in North America on the Lexus LS 430, becoming the first radar-guided Ford collision warning system offered in the U.S. 2004, in July 2004 the Crown Majesta Radar PCS added a single digital camera to improve the accuracy of collision forecast and warning and control levels. 2006, pre-collision system with the first driver monitoring system introduced in March 2006 on the Lexus GS 458 using a CCD camera on the steering column. This system monitors the driver's face to determine where the driver is looking. If the driver's head turns away from road and a frontal obstacle is detected, the system will alert the driver using a buzzer, and if necessary, pre-charge the brakes and tighten the safety belts. 2006, the Lexus LS featured a further advanced version of the PCS. Advanced Pre-Collision System, added a twin-lens stereo camera located on the windshield and a more sensitive radar to detect for the first time smaller soft objects such as animals and pedestrians. A near-infrared projector located in the headlights allows the system to work at night. With the adaptive variable suspension and electric power steering, the system can change the shock absorber firmness, steering gear ratios, and torque assist to aid the driver's evasive steering measures. The lane departure warning system will make automatic steering adjustments to help ensure that the vehicle maintains its lane in case the driver fails to react. Driver monitoring system was introduced on the Lexus LS. Rear-end pre-collision system includes a rearward-facing millimeter wave radar mounted in the rear bumper. This system adjusts the active head restraints by moving them upward and forward to reduce the risk of whiplash injuries if an imminent rear collision is detected. 2008 updated driver monitoring system added on the Crown for detecting whether the driver's eyes are properly open. It monitors the driver's eyes to detect the driver's level of wakefulness. This system is designed to work even if the driver is wearing sunglasses, and at night. 2008 PCS with GPS navigation-linked brake assist function on the Crown. The system, which is designed to determine if the driver is late and decelerating at an approaching stop sign, will then sound an alert and can also pre-charge the brakes to provide optimum braking force if deemed necessary. This system works in certain Japanese cities and requires Japan-specific road markings that are detected by a camera. 2009 on the redesigned Crown, Toyota again further advanced the PCS, adding a front-side millimeter wave radar to detect potential side collisions primarily at intersections or when another vehicle crosses the center line. The latest version tilts the rear seat upward, placing the passenger in a more ideal crash position if it detects a front or rear impact. 2012, higher speed APCS on facelifted Lexus LS. Enables deceleration of up to 37 miles per hour as compared to the current generation system of 25 miles per hour. This higher-speed APCS uses the same technologies as the current APCS. This system increases the braking force up to twice that applied by average drivers. 2013, pre-collision system with pedestrian avoidance steer assist and steering bypass assist can help prevent collisions in cases where automatic braking alone is not sufficient. such as when the vehicle is traveling too fast or a pedestrian suddenly steps into the vehicle unregistered trademark S path. An onboard sensor detects pedestrians and issues a visual alert on the dashboard immediately in front of the driver if the system determines that there is a risk of collision. If the likelihood of a collision increases, the system issues an audio and visual alarm to encourage the driver to take evasive action, and the increased pre-collision braking force and automatic braking functions are activated. If the system determines that a collision cannot be avoided by braking alone and there is sufficient room for avoidance, Steer Assist is activated to steer the vehicle away from the pedestrian. Volkswagen 2010, Front Assist. On the 2011 Volkswagen Touareg can brake to a stop in case of an emergency and tension the seat belts as a precautionary measure. 2012, in 2012, Volkswagen Golf MK7 introduced their proactive occupant protection, which will close the windows and retract the safety belts to remove excess slack if the potential for a forward crash is detected. Multi-collision brake system to automatically brake the car after an accident in order to avoid a second collision. City emergency braking automatically activates brakes at low speeds in urban situations. 2014, Volkswagen Passat B8 introduces pedestrian recognition, a part of the system. It uses a sensor fusion between a camera and the radar sensor. There is an emergency assist in case of a non-reacting driver. The car takes the control of the brakes and the steering until a complete stop. Volvo 2006, Volvo's collision warning with auto brake, developed in cooperation with Mobile, was introduced on the 2007 S80. This system is powered by a radar camera sensor fusion and provides a warning through a head-up display that visually resembles brake lamps. If the driver does not react, the system pre-charges the brakes and increases the brake assist sensitivity to maximize driver braking performance. Later versions will automatically apply the brakes to minimize pedestrian impacts. In some models of Volvos, the automatic braking system can be manually turned off. The V40 also included the first pedestrian airbag, when it was introduced in 2012. 2013, Volvo introduced the first cyclist detection system. All Volvo automobiles now come standard with a LiDAR laser sensor that monitors the front of the roadway, and if a potential collision is detected, the safety belts will retract to reduce excess slack. Volvo now includes this safety device as an optional in FH series trucks. 2015, entirely safe with auto brake at intersection. The Volvo XC90 is the first technology that features automatic braking if the driver turns in front of an oncoming car. This is a common scenario at busy city crossings as well as on highways, where the speed limits are higher. List of cars with collision avoidance features available. See also. References. Breaking the bank. Pre-crash systems are available now for a hefty price. Auto Week. Retrieved March 17, 2006. Keeping cars from crashing. IEEE Spectrum. External links, Crash Avoidance Technology Overview, IIHS, Ratings of Existing Crash Avoidance Systems, Insurance Institute for Highway Safety, September 2013. Argenia Railway Technologies. Collision Avoidance Systems for the Railways. U.S. Department of Transportation, Research and Innovative Technology Administration, Ford, Safer Driving Through Vehicle Collision Avoidance Systems, Intelligent Transportation Systems, Collision Avoidance, ERSEC Project, Enhanced Road Safety by Integrating EGNOS Galileo Data with Onboard Control System for Car Collision Avoidance Applications, Acumen Collision Avoidance Safety System, DSRC Wave Vehicle Communication and Traffic Simulator Texas.